All right, today we are going to talk about modeling and equation solving. And we are pretty much going to do this all with graphing technology. So you're going to learn a whole lot of calculator activity today. And it takes a while to get used to. So watch the video as many times as you need. After you do it a while, you won't need to watch the steps so much. All right. So when you're comparing numerical, graphical, and algebraic models, if they give you data, use a calculator or make a quick sketch of the graph by hand by plotting the points. And then we're going to fit a line or curve to the data. And we're going to use regression equations to do that on our calculator. If they give you the graph of the equation, use your knowledge of exponents to match the equations to graphs. You know that if you have a first degree equation, you have a line, like y equals mx plus b. In other words, x is to the first degree, y is to the first degree. That's going to be a line. If you have a second degree equation, like y equals ax squared plus bx plus c, highest degree is 2, that's going to give you a parabola. Okay, this will be a straight line. If you have a degree of 3, y equals ax cubed plus bx squared plus cx plus d. See how they just keep adding letters on to raise the degree? Alright, if you have a cubic function, you're going to end up with this S-looking curve. Which doesn't really look like an S, but it does when it's sideways. Anyway, you get this snaky-looking thing when it's degree 3. And if you have a square root function, like y equals the square root of x, then you get half a parabola, which looks something like this. Okay? So again, at some you can eliminate, especially on your homework tonight, they're going to ask you to match equations to graphs. Just your knowledge of degrees can eliminate so many of your choices. Okay? If they want you to use algebraic models, draw a picture, find a formula, or translate the words into an equation, and then use algebra to solve. If they are giving you graphical models, we're gonna learn how to enter our data in the calculator and draw a scatter plot. And then we're going to decide whether the data represents linear or quadratic. They're not going to do third degrees and square roots on you yet. Pretty much today, they're all either going to be linear or quadratic. And then you're going to use the calculator to calculate the regression equation. And to do that, here's your keystrokes. You hit the stat key, arrow over to calc, and then choose the regression that you want. And then some part of your homework is they're going to ask you to solve equations using algebra. This is basically trying to get you to review what you know about linear and quadratic functions from Algebra 1 and Algebra 2. So if they want you to use algebra, well, if it's linear, get x alone. If it's quadratic, you have all these choices. You can factor, you can extract your roots, you can complete the square, you can do quadratic formulas. And if it's a square root function, then isolate the radical, kill it, and then solve. And I'll show you how to do all that. Alright, so some calculator keys you need to be aware of. We're going to use this key a lot right here, stat. We are going to use the y equals function. We're going to use the graph key. We're going to have to set our window. You need to know where all of those keys are. Okay? Alright, so it says match the numerical model to the corresponding graphical model and algebraic model. Hold on just a second. Oh, yeah, so you're going to go to Stat and Edit. Okay, so you hit your Stat key right there, and you want to edit. Okay, then you're going to enter your X's for L1 and your Y's for L2. So under L1, and if there's junk there, all you got to do is get your arrow up to here, hit clear and enter, and that'll clear out all the previous data if someone else has put stuff in your calculator. Once those are clear, then I type my X coordinate, or my X numbers in for X for L1, and I type my Y's in for L2. Okay. Then we got to set our window. Who knows what the last person used your calculator. Always check your window when you're typing in new functions. Okay, so my window My smallest x is 3 and my biggest is 15. So I set my minimum at 2 and my maximum at 16, and I counted by 2s. My smallest y is a 6, so I set my minimum to start at 4. My highest is 30. I go a little bit past, I went to 32, and again I chose to count by 2s. Is this the only possible window that would work? Absolutely not. But it just has to cover your data. Okay, so then I'm going to go to y equals and turn my plot on, which means you hit your y equals key. Don't worry about that A, it's just when I took my screenshot. Alright, you want to make sure that plot 1 is black. If it's not, you just arrow up until you get over it and hit enter, and that'll turn it black, which means it's on. Okay, so then we can hit graph, and you should see your ordered pairs. There's 3, 6, there's 5, 10, 7, 14, 9, 18, 12, 24, and 15, 30. Well, I'm looking at it, and it looks to me like it's a straight line. Now, what that tells me is it can't be a second degree function, and this would be a second degree because x times x is x squared. It's not a square root function. This might work, it's linear. This might work, it's linear. This might work, it's linear. No way. This might work, it's linear, and this might work. So do you see how just knowing if I want a line, I know it can't have a second degree or a square root in it. So I've already eliminated 4 of my possibilities. Okay, so I know it's none of those. So how do we figure out which one it is? Which one it is? Well, we're going to make the calculator calculate the equation for those dots. In other words, I'm saying I could connect the dots with a fairly straight line, if not perfectly straight line. So the regression we're going to choose, you're going to hit your stat key again. This time you're going to arrow over to calc, and then you get to choose whichever regression you want. If it's a line, you're going to pick linreg. If it was U-shaped or quadratic, then you would choose 5. But I'm choosing 4 because I think this makes a straight line. And I hit enter, and it's going to ask me, where do you want me to get the information from? Just enter through all those. Continue to hit enter until you get right here where it says my lin regress is y equals ax plus b. A is 2, b is 0. And what that's telling me then is that y equals, change your a to 2, x plus 0, or just y equals 2x. So there's my equation. There's my algebraic model. And my linear model, I need the one that looks like this. Well, I know that it's got to go through 3, 6. That does not go through. They're counting by here. Let's see. They're counting by 2, so this would be 3, 2, 4, 6 would be right here. Nope. Here they're counting by 1, so 1, 2, 3, 1, 2, 3, 4, 5, 6. Nope. They're counting by 3s here, so 3, 6, 9, 12, 18. So 3, and let's see, they're counting by 4, 8, 12, 16, 20, 24, 28, 32. Yeah, they're counting by 4s. So you got to look at the scales. This can be kind of a pain in the butt if they would use all the same scales. See how I can't really tell from my picture because they extend that line down. So what I'm doing is I'm checking to see which line has that 3, 6 on it. I mean, I know it's none of the curves. Those are all out. Okay? And I've already eliminated those 2. So let's see, this would be 3. They're counting by 4. So 4, that would be 8. 6 would be somewhere in the middle. That could be it. Let's check the other ones. This is -1 to 16. So 2, 4, 6, 8, 10, 12, 14. Yeah, they're counting by 2s here. And 2, 4, 6, 8, 10. Yeah, they're counting by 2s here. So 3 would be here. 6 would be here. Nope. Nope. So it's got to be P. Okay. So my algebraic model for this is y equals 2x, and my graphical model is right there. Okay. Again, it'll take a while to get used to getting these windows and stuff. So I tried to write down the steps for you where you can come back to this and follow the steps as many times as you need until you get comfortable with it. And we'll do a few more. Alright, so on this one, oh, sorry, I finished it all on the last slide. So what is the answer? Well, again, we've got y equals 2x, and the graph we decided was b. Alright. Oh, look, I eliminated all the ones that couldn't be. And then our line has a positive slope, so I could eliminate that one with a negative slope. And then, oh, I typed it in, set my window. Oh, here I checked them all. And I saw if it would fit that. And it looks like it hit 0, 0, which looks more like D. And, oh, I see what I did. I actually went to y equals, typed that in, and then drew the line through it so I could see where it crosses the y-axis, which made it a little easier to pick out that it was D. And here I see how I changed my window to match his window, and I graphed it, yeah, and it's perfect. Alright, so it says on this one, match the numerical model to the corresponding graphical model. So again, we're going to go to stat, and I didn't put all the steps down. You can look on the last slide. I went to stat. I entered in my x's into L1 and my y's into L2. I set my window to go from, I think I went -5 to 8 and counted by ones. And on y, I went from -1 to 30 and I counted by, I think I went -5 to 30 and I counted by 5s. And that's how I got my picture. So from this one, I can tell that it's quadratic, it's not linear, and it's not a square root. Alright, so it's got to be, this was not that one, it's not a square root one. So it's got to be one of these. Well, I also can see that it opens up, so that one's out. So now I've narrowed it down to 3. And I also can get rid of, it's got to have an x squared in it, and it's got to have a positive x squared in it, if you remember from your quadratic days. A positive x squared means it'll open up, a negative x squared means it'll open down. So he's out. That's a possibility. He's out. No line, it's not a line, it's not a line, it's not a line, it's not a line. So I'm really down to these 3. Okay? So what I can do is I can calculate a quadratic regression. So I went to stat, then I went over to calculate, and then you scroll down, and I think quadreg is choice number 5. Now, what is this? This would be 1.3 e negative 12 would be this decimal 12 places left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. And we say, for all intensive purposes, then b equals 0. Alright, that's so small and so minute, we just consider it 0. So if a is 1, b is 0, c is 2, my quadratic equation, which says y equals ax squared plus bx plus c, if I plug in my ABC, I get y equals 1x squared plus 0x plus c. So my equation is, oh, looky there, x squared plus d. Okay? And if you look, I actually went and typed in y equals x squared plus 2, and it hit every dot. So I'm pretty confident that that is the correct equation. So my algebraic model is this, and my, oh, we got to figure out the graph. All right, well, it looks like, see how these either touch the origin or they're actually a little bit below? But mine is a little bit above. If I draw this, it doesn't touch that x-axis. So these two are out, which means it has to be f. So my algebraic equation is, what letter was that? P, Q, R is my algebraic equation, and f is my algebra. Algebraic if F is my graphical. Okay? Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 2. Alright, so when I typed this in, I took my L1s, my X's for L1s, my Y's for L2s, set my window. I'd probably set X to go from -1 to 8 and count by 1s, and my Y's, I think I'd start at -1 and go to maybe 40 and count by 2s or 5s or something like that. Okay? And then really what I do, I know this one's out, okay, because when I look on my calculator I can see it's a quadratic. So what I have to decide is which one of these goes through 1, 0. Well, again, we can't see the other half of it, which kind of makes things difficult. But again, how do you know it's this one and it's not? Well, I know it's not this one because this one doesn't go through 1, 0. It's too high. Really, between these two, it's kind of crazy. Like, they both kind of look like they hit 1, 0. So check another ordered pair. If I check 3, 8, 3, that'd be about 8. And here, that's only about 6. So that one's out, and it's got to be 2. Alright, solving problems using graphical models. Okay, we can also enter these data into the calculator and get a scatter plot by hand or on calculator. Decide whether the data represents a linear or regression or quadratic. Use the calculator to choose your regression, and then use the equation to answer the questions. Or you can use your table to find answers that way. Let me explain. Okay, so again, we're finding an algebraic model to represent the data. We're going to go to y equals, and I'm going to type in, oh, I'm showing you how to go backwards. Okay, what if you went and you had the equation and you needed to match the equation to this? So now if I go to y equals, I can type in the first one, x squared plus x. Pay no attention to that a, that was just from taking my screenshot. Alright, then I'm going to go to table to see if their table matches my table. So if I go to table and I start at 3, it's 312, 420, 5, is that my table? No. So I'm going to try another one. So I try the second one, and I type in x plus 1 times x minus 1. Again, pay no attention to that a. And I go to table, and I look at their table and my table. 3, 8, good. 4, 15, yep. 524, 6, 35, there we go. 7, 48, home free. 8, 63, we got it. So you can also start with the equation and then go to your table and try and match it that way. Alright, and so then if I look at the picture to match the graph, it looks like this. Okay, well, this one is obviously dipping below. I can get rid of the lines. That's gone. Doesn't open upside down. This is too high. Not a line, so it's these two. Well, I've got to decide which one of those it is. So I eliminated obviously the wrong ones. And I'm down to these two. So I check my window. I'm going to set it and go from -5 to 40. And I counted by 5. And I went from -10 to 650, and I counted by hundreds. And I hit graph. And does it look just like that? So I found it. Okay? You try this one, hit pause, come back when you're ready. And hopefully you got 60 minus, which I would have written y equals negative 2x squared plus 60, but whatever. Alright, so I went to stat, and I put my x's in for L1 and my y's in for L2. I set my window. The x window, I think I went negative 5 to 10. And y, I think I went 0 to 70. Alright, and I plotted the points. Well, that to me, it's saying choose the appropriate model. Well, I tried linear. I mean, I kind of look like a line, I don't know. I mean, I would have picked quadratic right away, but I thought, well, maybe it's linear. So I tried a linear regression. And the linear regression, which it kind of hits some of the points, it's close to them. That would be the linear regression. But I'm going to try a quadratic regression because, see, I have a linear here. I have 2 linears and 2 quadratics. Well, even if it was linear, it's neither of those, so it's not linear. So if I try a quad regression on the same data, notice how that's much better. See how the regression, if I type that into y equals and it draws over the dots, you can see that it hits all the dots. And so this tells me that a is negative 2 and c is 60. So y equals negative 2x squared plus 0x plus 60. But you don't have to write the 0, so it's just y equals negative 2x squared plus 60. And there you go. Alright, so how do you use numerical models to solve problems, algebraic models to solve problems, graphical models to solve problems? Okay, these 3, when you're answering them, talk about how you take the data, you type it in, and you get a picture of the data, and then you use that data to answer questions. Alright, so comparing pizzas. It says a pizzeria sells a rectangular 18 by 24 pizza for the same price as its large round pizza, which has a 24-inch diameter. If both pizzas are of the same thickness, which option gives the most pizza for the money? You're talking volume. Well, you're talking area, because they have the same thickness. So you're talking area. Alright, so an area of a rectangle is base times height. Area of a circle is pi r squared. So for my rectangular pizza, to figure out how much area of pizza I get, that's going to be 18 times 24, which I need my little calculator for. Hold on just a second. Alright, I'm back. Alright, so the area of my rectangular pizza is going to be 18 times 24, which gives me an area of 432. My circle is going to be, well, if my diameter is 24, then my radius is 12. So my area of my circle is going to be pi times 12 squared. Pi times 12 squared. And that gives me 452.39. So, which is the better deal? The round one, because you get more area means more pizza. Alright, it says Galileo Galilei spent a good deal of time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. His experiments are commonly repeated in physics classes today, so it's easy to reproduce a typical table of Galilean data. So your x's are the time that it takes the ball to roll, and your y measures the distance that the ball rolled. And it says, what graphical model fits the data, and can you find an algebraic model? Well, if we want a graphical model, they're telling me to graph. And again, I'm doing this on calculator. So again, I went to stat. I entered my x's for L1, my y's for L2, set my window. I think I probably went negative 5 to 10 on x, and I probably went negative 5 to 50 and counted by 5s on my y. Anyway, you should get those dots. So there's my graphical model. Can I find an algebraic model? Sure. Go to stat, calc, quad reg, and there you go. And you get my algebraic model is going to be y equals 0.75 x squared plus 0x plus 0, but that's going to be my algebraic model. And if you go back to y equals and type that in and hit graph again, it'll draw your equation over your dots, and if it hits all your dots, it's a good regression. Okay, so 2 says, how far will the ball travel in 12 seconds? Well, seconds is time, so that's an x. So we can say y equals 0.75 times 12 squared, and we type it in a calculator, 0.75 times 12 squared, and I get 108 inches. Okay. How long will it take the ball to roll 52 inches? This is a y coordinate because that's a distance. So now I want to change y to 52 equals 0.75x squared. I've got to get x alone, so I'm going to divide by 0.75. So 52 divided by 0.75 is 69.3 repeating equals x squared. To get x alone, I'm going to take the square root of both sides, and x equals the square root is going to be 8.33 if I round seconds. Okay, it's going to take 8.3 seconds. Or you can use the calculator. If I go, whoops, I guess I shouldn't put it right over where I wrote. If I go to my table, I'm looking for a 12 in the x column. So there's my 12, and you can see it went 108 inches, which is what I got. All right, the other way, I'm looking for 52. Well, what happens is I didn't get a 52. Like when I was looking up here, it went from 48 to 60. So it's somewhere between 8 and 9 seconds. So what I did is I went to my table set, which is your window key, the same but in blue, so you hit second window to set your table. I knew that 52 was somewhere between 48 and 60, which means my time had to be somewhere between 8 and 9. So I started my table at 8 and counted by 0.1s. I still didn't hit 52 exactly, but it was somewhere between 8.3 and 8.4, and I got 8.3, and that's pretty darn close. Okay? All right, so you try this one, hit pause, come back when you're ready. And hopefully you got F3. Here's what I did. Okay, I went to stat, put in my x's for L1, put in my y's for L2, set my window. I think I set x to go from 0 to 100 and counted by tens. And I set my y to go from, I think I started at 800 and I went as far as 2500 because my biggest was 2490. Okay, and those are my dots. Okay, that tells me it's quadratic, so I shouldn't even need to check these two. It's going to be between these two. But just to show you, I checked them. If I typed in, here's my data. If I went to y equals and I typed in y equals 2000, it graphed it. Does that fit the data? No. So then I typed in 40x plus 1000. No. So then I typed in F3. Ooh, hit quite a few of my dots. And then I typed in F4. No. So the best one that fits the data would be F3. Okay? Again, focusing on these three questions. We'll get to that tomorrow. All right, so the last part of your homework is solving stuff algebraically and graphically. All right? When you're doing algebra with square roots, your goal is to isolate that radical, which you call a square root, but it's a radical, and then eliminate it by raising both sides to whatever the index is. The index is that number right there, and then get your variable alone. So I need to isolate this guy, so I'm going to add x, and if you don't mind, I'm going to do two things at once, and I'm going to, well, I probably better not do that. So I get 1 plus the square root of x plus 4 equals x. Then I'm going to have to minus the 1. So I have the square root of x plus 4 equals x minus 1. All right, now from your algebra days, hopefully you remember, to kill a square root, you square, but I got to do it to both sides. Excuse me. On this side, the square kills the square root, and I just have x plus 4. On this side, to square that without killing puppies, you have to make 2 copies and FOIL. So I would get x squared minus x plus 1, which gives me x squared minus 2x plus 1 equals x plus 4. This is quadratic, so I want to get 0 on one side. So I'm going to move the x. That gives me 4 equals x squared minus 3x plus 1. Minus 4. I get x squared minus 3x minus 3. Okay. I'm sorry, this is all equal to 0. Well, 0 on the other side. So now I have this guy. X squared minus 3x minus 3 equals 0. If I try to factor this, I'm looking for factors of 3 that make 3, which don't exist. So I'm going to have to do quadratic formula, which says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, in case you forgot your quadratic formula. A is 1, b is negative 3, c is negative 3. So x equals a negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 3 all over 2 times 1. That gives me 3 plus or minus the square root of 9 plus 12 is 21 all over 2. So x equals 3 plus the square root of 21 divided by 2, which is approximately 3.79. And the other one, 3 minus the square root of 21 divided by 2, is x equals negative 0.79. There's algebra. Graphically, there's my equation. Okay, and this one we are going to throw out, and it has to do with that square root. Okay, so, and if you look at the graph, there's where it crosses between 3 and 4. If you go to calculate, second trace key, okay, not in stat, just hit second trace, and you calculate when you're trying to solve, you're looking for zeros. So I choose 0, and then it's going to tell me I have to pick left bound, right bound. You'd stop somewhere here for your left bound, and you'd move it here for your right bound, and then it's going to ask you right bound, left bound, do you want to guess? Just hit enter 3 times, and it'll zoom in on where it crosses the x-axis, which is at 3.79. Okay. The other one is negative 0.79, which I'm not really sure why that's not working. Oops. But it has something to do with the restrictions on the domain. Alright, so if we solve this one algebraically and graphically, it's not a square root, but it's a square. I still need to isolate it to kill it. So I'm going to add 81. And I get x minus 5 squared equals 81. To kill a square, I'm going to square root both sides. That gives me x minus 5 equals, on this side, it's plus or minus 9. Because when you square root, it's always plus or minus. So that gives me x equals negative 5 plus 9 and x equals negative 5 minus 9, which gives me x equals 4 and x equals negative 14. And if I do it graphically, okay, I went and I typed this in for y equals, and I calculated my zeros again. This one over here. Now this would be you'd stop here for your left bound and here for your right bound to get this 0, which you can see is at negative 4. Oops, I'm in schmo. Add 5 is 14. Add 5 is negative 4. My bad. So there's your negative 4. And then I do it again. I calculate here, but this time, guys, you're always reading from the left. So now your left bound, you're going to stop below and then pass it, and that will be your right bound. And you can see that that's at 14. So there's my two solutions, algebraically, graphically. All right, so this one, I've got to isolate this radical. So I'm going to minus x, 6 plus 3 square roots of x equals negative x plus 10. Move the 6. I get 3 square roots of x equals negative x plus 4. And then I should divide by 3 before I square, but if I divide by 3, I'm going to get fractions, and I don't like that. As long as you don't have anything else added or subtracting, you can go ahead and square both sides. But that's going to make it 9x, because 3 squared and then the square root of x squared, that's 9, that's x, yes? On this side, so I don't kill puppies, I make 2 copies and FOIL. That's going to be x squared. That's going to be minus 4x. That's going to be minus 4x, and that's going to be plus 16. So if I clean this up and get 0 on one side, because it's quadratic, I'm going to minus 9x. And I get 0 equals x squared. I got negative 4 is negative 8, negative 9 is negative 17x plus 16. I could do quadratic formula again. This one should be an easy factor though, because a is 1. So x and x. Factors of 16 that make 17 would be 1 and 16. Since I add, they both take the sign in the middle, which is negative. And that tells me that x minus 1 equals 0, or x minus 16 equals 0. Add 1, I get x equals 1. Add 16, I get x equals 16. So those are the two solutions I'm expecting. If I go and graph it, I get, there's my 1. And again, this one would be way down there somewhere, but it's not. It's going to be a square root function, so this is just going to keep doing this. So again, this one would be extraneous, and it has something to do with the domain. Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 9 minus 4 square roots of 5. Alright, I need to isolate this, or at least this, so I'm going to minus x. I get 4 square roots of x equals negative x plus 1. I'm going to square both sides. That gives me 16x equals x squared minus x plus 1. Subtract 16x, I get x squared minus 16, 17, 18x plus 1 equals 0. And there's no way factors of 1 would make 18, so I have to do quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That gives me 18 plus or minus 18 squared minus 320 all over 2. They don't go decimal, so if I break down 320 by 2 is 160, by 2 is 80, by 2 is 40, by 2 is 20, by 2 is 10, by 2 is 5. 2 2's, that's the square root of 4, which is 2. Square root of 4, 2. Square root of 4, 2. He doesn't have a partner, so he's back in. So I can write this as x equals 2 times 2 is 4 times 2 is 8. So 18 plus or minus 8 square roots of 5 all over 2. And then if I cancel out or reduce by 2, I get x equals 9 plus or minus 4 square roots of 5. Which should be 3. Oops. Yeah, it should be 3. Sorry, my bad. Alright. And there's where it crosses at 0.0557, blah, blah, blah. And if I type in, oh, that's why, because the positive one is extraneous. So 9 minus 4 times the square root of 5 is 0.055, blah, blah, blah. Alright, so again, answer those 3 questions. Oh, explain why this can't happen. Well, the zero factor property only works if the other side is 0. It can't be 43. Factor property only works if right side equals 0. Okay. Alright, so we are at homework. Done. So happy homeworking, and I will see you next time.